Well, a little few words about FIWARE. Most probably many of you who are joining know already, so I will not spend so much time, but as we always say, FIWARE mission is to build an open, sustainable ecosystem around the creation of standards that make it easier the development of smart solutions in multiple sectors. And from the FIWARE community, what we do is we contribute to the creation of such standards when they do not exist. And the mean and the way we convey this creation of a standard is by following an open source implementation-driven approach. And but also, and this is very important, how to solve how different standards can be integrated, because in many cases the challenge is that there are multiple standards already existing, and there is a difficulty and not a good understanding how those standards can be integrated. Actually, this is, I think, one of the main challenges with regards to data spaces. There are a lot of standards that are emerging, but emerging separately and disconnected from each other. And what we have been able to achieve in FIWARE when developing this vision of data spaces is to precisely come with a good understanding how those standards can be integrated. And well, the members of the FIWARE community, together with technical staff from the FIWARE Foundation, we actively participate in all those relevant bodies where the relevant standards for creating smart solutions or ecosystems around the smart solutions are going to be defined. And as I said before, what we try to do is always to drive and to influence the direction those standard bodies or industry bodies are taking by means of bringing ideas based on actual implementation experience. And this is what we are doing with ETSI, for instance, where we are bringing all the contributions to the NGSI-LD specification, which is the basis for standards for creating solutions based on the digital twin concept. And that is also what we are doing when we contribute and participate in bodies like the International Data Space or GAIAX and so on. The standards we are advocating for has been adopted widely. I would say, and I think we can say proudly, that those standards have become like the de facto standard in smart cities worldwide. But adoption is growing in other domains, ports, destinations, agri-food, and this is really a great thing. From our point of view, data spaces are bringing the opportunity for all those organizations that were using FIWARE technologies to digitize and break information silos to go to the next step in their digitization. We will cover that today. But even the kind of data space technologies we implement could be used even for organizations that are not currently using FIWARE in their architecture, but are willing to join data spaces. So one key takeaways I would like that you bring with you is that the components and the technologies that FIWARE offer for creating data spaces do not require that organizations using those technologies must implement a FIWARE architecture. Of course, those who already implement a FIWARE architecture will really go and evolve to be able to join data spaces in a very smooth way. FIWARE technologies have been used for breaking information silos, adopting a system of systems architecture based on digital twins. This means, for instance, in cities that what we do is we establish how each vertical system in the city, like it could be the smart parking solution, traffic control solution, air quality monitoring system, can inject data into a digital twin representation of the city that we keep up to date in almost near real time. And each of these systems are reporting data that feed up this model, this digital twin model. Like, for instance, the smart parking system may be reporting how many parking lots are available in a given street, or the air quality monitoring system can report the air quality levels of each street, right? On the other hand, those systems take benefit on the fact that everyone is feeding with data this digital twin model, and relying on that, they can consume the data that might be generated in other systems for their own benefit, for improving whatever process each vertical system implement. Therefore, for instance, the traffic control system, for instance, can retrieve information about the pollution in a given street that has been fed up by the air quality monitoring system, but that is transparent to the traffic control system. And this is a key and essential concept that we support in any FIWARE solution. This decoupling between the source of information and the consumers of those information. With this digital twin representation that sits on the core component in any FIWARE architecture, which is the FIWARE context worker, cities, for instance, are capable to implement their smart city operations support systems, or what is called, in some cases, integrated command and control systems, and being able to, merge all kind of data to extract more valuable insights, and with this, be able to support smart decisions by the city operators, or further automation of different processes. And that is a model that has already proved and worked in the agri-food sector. We do not talk there about smart cities systems. We do not talk there about governance system, but is in a way also a sort of integrated command and control. These kind of systems are called farm information management system, and what we have been enabled with FIWARE is the creation of these kind of systems that are capable to integrate different vertical applications that a given farmer may be using. There are two great examples within our community. Animal, for instance, when we talk about livestock management, or agriculture, when we talk about agriculture farming. And in a way, the same approach is followed, which is that of having each of the verticals that you integrate, that this farm information management system integrate, feeding up with data that contribute with information that enables to create this digital twin representation, and each system being able to get access to that information which sits in the context worker component to be able to encase or further and trigger actions within their own applications. These farm information management systems based on FIWARE can exploit data from all verticals, and actually is the kind of systems that assist farmers in the various tasks that ranging from operational planning, the implementation and generation of documents that typically you may need to report to public administrations for assessment of the processes that have been performed. So with this, what I explain is FIWARE has brought a bit the vision how a map of systems can be created, this kind of architecture for enabling digitization of cities, farms, and this kind of pattern can be replicated in other domains. But what is a bit the next step in digitization? And with this, I'm trying to explain what data spaces are intended to bring. In the traditional architectures that we are supporting, the different systems are running on the same cloud environment. It could be a private cloud, can be a public cloud, but typically are sitting in the same environment, in same cloud infrastructure. What it would be, or in a premise and within an intranet. And the next natural step would be that of trying to extend this map of systems with systems that may exist outside the boundaries of the cloud infrastructure or the premises of the given organization. The idea would be to be able to integrate systems from third parties, which may be of different kind. There might be some vertical smart solution providers. If we are talking about a city, there might be an application provider that is bringing a solution for managing parks and gardens. And we would like to be able to integrate that solution that might be provided as a service from the cloud, right? There might be also AI services that I may want as a city to also integrate with my map of systems. I may have already a traffic control system that might be deployed in my intranet or my private cloud, but does not incorporate some, prediction services for traffic based on whatever new AI algorithms. I may be willing to integrate AI services in a product that some provider is offering from the cloud, and that service provider intends to keep that service in their own cloud infrastructure, and you need to integrate that within your map of system. You may also be willing to integrate data services from third parties. I mean, a good example would be weather services, when we talk about a city, right? I may want to integrate those services from an agency that may be offering that from the cloud, and be able to exploit that information for enriching this digital twin representation that I may have already, but which was missing that data that now this agency may be providing. Furthermore, I may be willing to integrate information from other organizations which may be based on FIWARE or not, but which may provide valuable data associated to their operations that I may be willing to integrate. For instance, I may be willing to consume and rely on data that a logistic operator agrees to share. Maybe I'm paying for that, I may be willing to pay for that, and is information that would allow me to improve, considering the routines and the schedules that they have for delivery, better understand how traffic will evolve in my city and what measures I can take to improve that traffic, for instance. Going further, the cities themselves may be willing to offer data that they generate, they maintain, or they are able to produce based on algorithms by means of these valuable insights I was mentioning before that it could generate by means of merging data and considering history and all that information. So question is, okay, how the city is able to offer this from the cloud as a service so that, for instance, a logistic operator can also use those services. There could be, in that sense, a nice exchange between the two organizations. The logistic operator being able to share with the city the planning and the schedule of deliveries that it has, so it is taken into account when planning traffic control. On the other hand, the city being able to offer also data about traffic, data about access rules and policies that they may establish that the logistic operator need to take into account when doing planning of routes and everything. So this is something that somehow we need to support, and in this idea we would be breaking a bit the frontiers of the existing solutions where a given organization has an intranet, and every system is in the internet, and relying on very concrete integration technologies and identity and access management technologies and so on, be capable to integrate solutions that may be, and services that may be offered by other organizations, but also helping to establish an ecosystem where solution providers of different kind, application providers, AI service providers, data service providers could emerge, and you can integrate them easily. As something I put the example of a city, but of course would work as well for solutions in other domains, or use case in other domains. At the end of the day, what would be the vision we are targeting to is that of creating a sustainable, innovation-driven ecosystem. But that would require a number of things. These organizations that we want to that emerge offering data products should come with formulas and tools and technologies enabling them to publish their offering, publishing the terms and conditions associated to the offerings they provide. Organizations that are interested in consuming those data products need to know how those products are published, where they can find the information associated to those products, how to discover them, how to acquire the rights to use those data products. In many cases, those products may require sophisticated provisioning and activation process before you start using them, and you need to come with ways how this gets solved. You need to be able to support how these product providers can monetize their products, because this is what ultimately will make the whole ecosystem sustainable. And last but not least, you need to come with mechanisms that make it easy to integrate whatever data product is brought into the ecosystem. And this, if we talk about cities, is what would mean a fully evolution of what had been the traditional open data strategy, moving towards a full vision of what we may consider a data economy. In farming, we have a similar situation. The farm information management systems already integrate a number of base applications and to solve basic process management, resource planning. They may come with specific applications connected to some problems that the farmers they are targeting are facing. But one important characteristic in the agri-food sector is that no farm information management system provider can pretend to implement the full range of applications that can be useful for each farmer. So it would be ideal to have an approach how farm information management systems can enrich and bring and arrive with a catalog of applications from third parties that farmers can find and activate in connection to the base applications that the farm information management system provides. So it's a bit different flavor, but at the end of the day, if we talk about agri-food, if we talk about cities, we may go into other domains. The whole intent is moving towards creating an ecosystem that brings mechanisms for application providers, product providers to emerge and offer those products as a service, mechanisms that allow potential consumers of those services to integrate in the farm information management system. If we are talking about farming in the a smart city platform, if we are talking about a city, those applications, no matter where they are located and hosted, maybe on the cloud, maybe on the edge, but they don't need to be co-located with the rest of applications that the city or farmer are using. And all this has to be made in a very easy manner. And the fact is that this is not something that was easy today, but in our vision with data space technologies, we will be able to solve the different problems that we would be facing. What are those problems? What are those challenges? And why we need data space technologies, or let me say differently, why data space technologies come to bring solution to those challenges. Well, first of all, organizations, as we say, need to extend their system of systems architecture with systems offered from the cloud by a third party. But today, or let's say before data space technologies were in place, this required that the consumer organization had to register its users in whatever identity management service the provider of a product it wanted to use was offering. So if I were a smart city and there is a parks and garden application, that parks and garden application would be offered as a service. That's fine. But then inherent to its design, it would consider different kind of users with to which they would assign different access policies. So, for instance, these parks and gardens may distinguish between gardeners that are capable to activate watering mechanisms remotely from their applications in a given park or part of a park, a garden within a park. But they may also consider citizens as potential consumers of their system, and citizens that may be willing to simply know what is the temperature in some part of the park, or what is the level of pollution of pollen particles and that sort of stuff. And it is obvious that such kind of application would not allow all users to do all kind of actions. I cannot allow a citizen to be able to activate the watering of a park. So there needs to be identity and access management. Now, if we are intending to create an ecosystem like this, just imagine if each of the product providers come with their own identity and access management service, and that, so that the city has to register for each and every of these products the different users, and in whatever identity management service that product provider relies on. That would be, a total burden. This really becomes a barrier for organizations to be able to incorporate systems from third parties, products from third parties in their current map of systems. If each of them not only come with a different service, but also with different technologies, different standards. One use WAF, another one use LDAP, others any other kind. that would be a nightmare. This would be really a barrier. So one of the things that would be required is to come with some sort of first, a standard commonly agreed to be used for identity management, and the second, very important, an identity management framework that allows each organizations to be able to manage their own users and not need to register them in any sort of database or service, sort of user management service that a given data product provider provides. So that's one challenge that was not solved before, and that was a limitation that was preventing organizations to extend the architecture of systems they had with systems and from different parties provided as a service on the internet. A second challenge is how you define these access policies. I mean, this product provider, I was putting the example of Parks and Garden, defines, and that is part of the description of their product, a number of policies that determine how, which users can do what actions. And for instance, in Parks and Garden, what are the actions and the queries that a gardener can do and what a citizen can do, and there might be other kind of users according to the business logic of that application. And now imagine if another application provider, another product provider comes with a different way to describe those policies. That would be, again, a nightmare. I mean, if me as an organization wish to integrate products from multiple providers, and for each and every of them, I need to understand a different language, how policies are described, enforcement policies are described, and so on, that would be really a barrier. So we need to come with standard language, how policies to be enforced can be specified, and have a good understanding how those policies may work. Another aspect is actually how you exchange data. We know that there are people that are skeptical about setting up a standard for how data can be exchanged, how services can be invoked, but definitely within FIWARE, we advocate for trying to define a common lingua, because that is what will trigger and boost the plug and play integration of services associated to products from different providers. And if I have in my organization, my map of systems, and I wish to integrate systems associated to providers that are offered as a service on the internet, and the mechanism for invoking a service and getting the data that I wish to obtain is different, this is a nightmare. It would be ideal to come with a common API, common data models that would allow this plug and play approach to be feasible. Last but not least, we are talking about products that I want to integrate in my system, and as we will see later, this might not be that easy task. We are not talking here about like when you go with your mobile, you go to the App Store and you find a given application and just click download and install, and this gets into your mobile. Things are not going to be like that when we are talking about systems in existing organizations and how you integrate a system from a third party. Among other things, because the service those parties may be providing may require that a number of resources get provisioned and activated. Let me follow again with the example of parks and gardens. I mean, this parks and garden application provider may be offering a solution that anyone can integrate for managing the park and the different gardens, but it will require to deploy certain devices for watering, for measuring air quality in the park, and a number of things. This is part of the description of the product, and the provision of this is not just something you do with just one click. Is something that may require that the city deploy the devices with probably the help of some sort of integrator, that once those devices have been deployed and they, by the way, have to follow certain characteristics that should be described as part of the characteristic of the application, there is the need to go through a number of steps linked to this provisioning of the devices and the activation of a connection between those devices with the backend system of the product, and so on and so forth. And only once all this has been done, then is when the service can start being used. It would be ideal that the steps, the model, and the way you provision services, the way you provision products that incorporate or imply the provision of services, the provision of resources, not only in the field, but also in the backend and in data storage that is required, and so on and so forth, virtual machines, whatever, computing capacity. It would be ideal that this process of provisioning activation is following some sort of standard. Why? Because that would make it much easier to integrate multiple data products, and once you know and get known how to do it with one provider, then it will be easier with the rest, and so on and so forth. And it will be also ideal that the way you are going to be charged and providers, how they will be paid, gets also somehow standardized. And this is what the answer to all these challenges is, what data spaces technology really bring. That's how our definition of data space comes. And the data space in that sense is something, is an ecosystem at the end of the day that is built around commonly agreed technologies. We may call them building blocks that solve the challenges we have explained, that can be categorized in three major pillars. One is those challenges about data interoperability, how participants actually exchange data, how they invoke services, and as a result of invoking those services, they get some data in return, and that implies defining protocols and data formats. It also requires how trust between the different parties accessing data can be verified, how to implement this concept of decentralized digital identity, and how this concept that we were explaining of how policies for access or for usage control can be defined and enforced. Last but not least, you need, and this is going to be also very important, means for publication and discovery of data products, offerings around them, how to provision and activate them, and after negotiation of the corresponding contract. And essentially, data spaces have to do with agreeing what are the standards we are going to follow in each of these three pillars. Okay. Of course, it's not just about technology. There is the notion of governance also associated to a data space. In the first place, you need a governance to be able to establish which are the standards that will be followed. There might be different versions of the different standards, so which version is going to be used at every moment by all participants, because there should be such governance to make an agreement. If we are talking about data models, for instance, which is essential for data interoperability, not only what API you use for data exchange, but also what are the kind of data models and around which you exchange, so that participants understand each other. There should be governance of such data models where there should be some sort of, for instance, repository where data models that have been commonly agreed by the participants in the data space will be published, for instance. So there are a number of governance elements. Also, legal aspects are in place. For instance, participants, you may be willing to feel secure that, if you have established certain terms and conditions on the usage of your data, this is something that will be preserved. We are looking towards, of course, technologies that, in the end of the day, in the future, they will be able to support usage control, but that is technically very difficult today. And you may need to rely on legal frameworks that somehow at least give you some guarantee that, okay, I established certain terms and conditions, and you sign, because when you join the data spaces, you sign a legal framework that all the participants agreed to sign, which establishes that you cannot break those terms and conditions that a given provider has established. So these governance aspects that have to do with business, operational, and organizational agreements are a fundamental aspect of data space. That's the reason why and this is a bit of a taxonomy and a picture that comes from previous work in a project called Open Day, how we describe what could be the building blocks in every data space. But very important, and the major takeaway you have to bring with you after this webinar is you need to come in each of these 4 pillars and with agreements between participants. When we talk about the technology pillars, data interoperability, data sovereignty and trust, data value creation, this means about coming with very concrete set of technology standards to adopt. When we talk about governance, it has to do with, agreements, operational, business, or organizational that you need to put in place. And that means, by the way, that within data spaces, intrinsically, there is the notion of a data space authority. You need to establish some sort of governance, bylaws, whatever you want to call it, that establish, all these aspects that need to be governed, as we said. If we see more how a data space may look like from an architectural perspective at very high level, of course, at the end of the day, this comes into organizations. They may be data product providers, and when I say data product providers, they may be data service providers, they may be AI service providers, they may be application providers. All of them is what we refer to as product providers, and each of them will have to, both organizations and product providers, be able to connect to the data space through a specific component, which is what we refer to as the data space connector. There needs to be a registry of which are the participants, which has signed up these agreements that have been established for the given data space, and not mandatory, but I think a good practice is that of having some global services within the data space that will allow participants to discover what are the data products that are available for integration, how they can be, therefore, how they can acquire the rights to use those data products, and what are those terms and conditions, and for that, some sort of marketplace or catalog service is a common good practice. We in FIWARE essentially are trying to bring all these pieces. We have components that allow to set up marketplace and catalogs that can work. It's global for the data space. Nicely, the components we have implemented in FIWARE are precisely the basis for a marketplace that the European Commission is setting up across Europe for offering and publishing the offerings of data product providers. And this is the project called DOM. But what we will be focused along these webinars will be mostly on the elements and the components that allow us to set up a data space connector in each and every organization that connects to a data space. The concept of data space connector is a concept that has evolved over time, but I think nowadays there is, I think, a good consensus in practical terms what it means. It is, in a nutshell, a number of components or modules, if you wish, that are deployed and configured in a control environment. It could be typically a Kubernetes cluster that each organization has to set up, and where a number of functions will be implemented and are essentially functions that have to do with those standards, with the implementation, with the support of those standards that we explained before, that need to be supported by every participant in the data space. And these will be modules for implementing the authentication, for implementing authorization, for implementing how to support access to the APIs that will trigger services and invoke those services and be able to capture the results. Functions for publication of characteristics of the services that are being exposed through the connector, functions that will be very important to be able to manage how a consumer will be able to acquire the right to use a given data product and will be able to manage the life cycle associated to the provision and activation of resources and services linked to that product. Remember the example that I gave before about the Parks and Garden application. It will incorporate components for logging, because of course you need to be able to understand how the whole connector works and behaves when running. Coming back, so this vision of a data space connector as a compendium of modules that are deployed and configured in a control environment is something that actually was finally adopted in the IDS RAM architecture. So I think in that sense we are all pretty aligned. Let me now elaborate on some key concepts. I have been mentioning some of the terms, but I would like to go a little bit and be more precise on certain aspects of what would be the kind of a conceptual model for data space that we support with FIWARE Data Space Technologies. And it's important to understand these concepts because many of the aspects are going to rely on these concepts. So first of all, this concept of product, services, and resources. In our vision, a participant in a data space can typically play the role of a provider or a customer of a product, a data product. And a data product is not simply a data set. Our vision, and I guess you have been capable of already guessing with what I have explained so far, is not as naive or basic as, okay, data spaces is about participants exchanging files or data sets. No, really, data spaces is about enabling an ecosystem where organizations can integrate in their map systems that are being provided by third parties, and those systems we call products or data products can be something really sophisticated. It can be a combination of services and resources, and some of these services provide access to data or processing of data or even web pages and graphical user interfaces. So again, if I come with these, let me put another example, an air quality monitoring product. this product may come with a web page that allows you to connect to the air quality monitoring solution and be able to see through very nice dashboards, how the data from the streets in your city is evolving. You can see maps, heat maps, and regarding how air quality monitoring measurements evolve. You may be through those web interfaces be able to see prediction, trigger predictions, and so on. And of course, there might be services for applications, not just for end users. There might be a set of APIs being exposed that allows you to get access to the different measurements of air quality that the product is managing, is gathering. It may come with APIs and endpoints associated to those APIs through which you can invoke and ask for predictions about how these air quality measurements will be evolving. And not only services, those products will come with typically resources that are required for the execution of services. So, given quality monitoring product, when instantiated for a given customer, like a city, will come with the resources associated to the storage, how much storage is being used for, has been contracted to gather and store the history of air quality measurements. It will come with what are the IoT devices actually deployed in the field that are capturing the measurements, sending them to the air quality monitoring product. Those products are that sort of complex. And very importantly as well, products and therefore their corresponding services and resources are provisioned and activated for each particular customer. And this provision and activation is something that may not be in just one click. It may even take days, right, or weeks. And not everything, and that's also another important feature, runs on the cloud. There might be products that somehow in their own architecture are spread and distributed from the cloud to the edge. That is the example of actually the air quality monitoring solution, where there is part of the architecture that is going to run in a backend operated by the air quality monitoring product provider, but there are part of the architecture, the devices, for instance, that might be deployed in the field, close to the customer. One important aspect that we intend to support is that the description of whatever product will be based on a number of characteristics, but those characteristics may, or at least some of those, will be modeled through verifiable credentials. Verifiable credentials is just a bit a way to represent in JSON-LD the given characteristics or a number of characteristics around that subject. And in our case, verified credentials will not be used only for managing identity and access, but also managing the description of products. So, for instance, there might be characteristics linked to a product which has to do with whether that product complies with GDPR recommendations. when that happens, there might be a verified credential associated to that product that, precisely has been given away by an agency and certifying that that product complies with the GDPR regulations. Similarly, there might be characteristics that have to do with what sort of protocol is supported for invoking services linked to that product, and what are the data models, for instance, that that product supports when someone invokes a service and use data according to those data models as input or for capturing the results of such services that are invoked. And you may come with, for instance, description that they are HSILD compatible, and you may have credentials certifying that. Okay, so bottom line, providers offer products. Those products are based on published specifications, and typically products are a combination of services and resources, which in turn has their own specifications, and for some of the characteristics of both product, services, and resources, there might be verified credentials that may have been generated to kind of certify that the product actually is supporting those characteristics. And what a product provider typically does is to describe or define offerings around those products. And those offerings will include a number of characteristics like terms and conditions, pricing, and a number of things. When a given consumer acquires the rights to use a given product from a given provider, what is generated is an instance of that product for that particular consumer. So this is also something that needs to bear in mind. Like the same product might be being offered to different parties in the data space, and whenever each of these parties acquire the rights to use that product, a specific instance will be created with the provision of all the corresponding services and resources to serve the needs of that particular customer. And this goes through a product order, right? A product order that is what a customer organization who is interested in consuming a product, or well, indeed consuming any of the services associated to that product, would need to trigger. And very important, and I need to insist in this idea, completing a product order, which means that a new instance of a product is created, is something that may take time, may take days, may take weeks. But what is interesting is that in the kind of standards that we are supporting in FIWARE, this idea of life cycle of data products which go and transition through different states until they get finally provisioned and activated is something that is well supported and following concrete standards we have adopted. We'll come later with what kind of standards. What it means acquiring rights to use a product or service. Well, we in FIWARE data spaces and we are relying on verifiable credentials for the management of identity. Let me think, because maybe, okay, we came with the slides describing that. But essentially, what is this concept of verifiable credentials? Verifiable credentials essentially are, if I make an analogy, similar, bring to the digital world essentially the concepts of identity you have in the physical world when you use cards for identifying yourself. Those cards, and this might be, for instance, your national ID, but might be the card that that one given club gives to you, issues for you whenever you join that club, are elements that somehow represent your identity, and incorporate a number of credentials associated to you that the issuer of that card has decided to give you. If I'm a member of a club and I get a card that identifies me as member, the club has issued that card, and that card is giving me the credentials that I'm a member of the club. And with those credentials, I can go to the club and may say, okay, I want to enter and enter the club because I'm going to do my training. And I don't need, and this is very important, I don't need to tell anything about who I am or certain data that I want to be to keep private. The person that is in the door, or the system that is in the door will simply check that this card that you are presenting has been issued by the owner of the club, and if that's the case, it will allow you to pass. So similarly, in data spaces, what we have adopted, and it's not just FIWARE, is the approach that all the organizations within the Data Space Business Alliance have decided to follow. We have decided to rely on the concept of verifiable credentials and protocols associated, like OpenID protocols for verifiable credentials. We have all agreed that this is the basis for the way we will perform identity management, right? So what it means acquiring rights to use a product or service in a given environment. Let me illustrate this with an example. Again, with the parks and gardens, I'm a city. I want to integrate the parks and garden product into my map of systems, and that product understand about gardeners, understand about citizens, right? And these are the kind of credentials that they will check whenever someone is going to invoke a service that park and garden application offers. So if someone tries to invoke a service for watering a garden, it will check, do you have the card that gardeners need to show? Because if you don't show me that kind of card, I will not allow you to invoke that action, right? And same if you are not a citizen, I will not allow to query, for instance, for information about the pollen particles in the park. Question is, and here is where the magic comes, is that the application provider, in this case the Parks and Garden, does not really care how many gardeners are there, how many citizens are there, and how those gardeners and citizens have been given the card that he understands and he will check. They only need to make sure that whoever has given to them those credentials is a trusted issuer of those credentials. In our case, when a city acquires the rights to use the Parks and Garden application, and probably for that we have signed a contract, he has become a trusted issuer of the credentials gardener and citizen. And what is interesting and very important, because remember was one of the challenges we needed to solve, is that the city is the one who decides whom they issue those credentials. So the city will determine, okay, these are my gardeners, I will issue to them the verified credentials of gardeners. To all my citizens, I will provide some sort of portal so that they can gain the credentials as citizens of my city, or might be citizens or visitors, and it depends on a bit of the policy that I want to implement. And each of these users will have in their wallet, there is the concept of wallet associated to verifiable credentials. They will have those credentials stored in their wallet, and whenever they go and invoke the services of the Parks and Garden application, essentially what that Park and Gardens application will do is first it will check, is that credential of a gardener coming from a valid participant, a trusted participant of the data space first. Second, does it come from someone which previously acquired the right to use my product? Because if not, I will not recognize that credential, that card is showing to me as valid. With this, we supported a key advantage, which is the management of the users belongs to the consumer applications. The application, the product providers, no longer become the ones who own and manage the users of their services. This is delegated, this function is delegated in the consumer organizations. When this verification takes place, so the credential you are showing to me has been issued by a trusted participant and a participant that had previously acquired the right to use my service, I will then implement and enforce the policies that are linked to the business logic of my application. So if I do not allow a citizen to invoke the service that will trigger watering of a garden, that would be a policy that is implemented in the backend of my Parks and Garden product. And that is, by the way, it's a policy that is described as part of the description of my product. And if a citizen comes, he may have a valid credential, and a credential that has been issued by an organization I trust as issuer of that credential. But with that credential, sorry, you as a citizen, you cannot water a garden in the park. If you are, on the other hand, a gardener, I will check first whether your credential had been issued by the valid party and the party that had acquired the right to use my service. And if so, yes, I will check, and the gardeners can actually invoke this service for watering fields in the park, and therefore I will allow you to your request to pass through. This is a fundamental idea and how we are solving one of the main challenges that we were enumerating before. Well, we could be talking for hours, but in a nutshell, what I want to convey as a message is that we come with a very complete and comprehensive model that supports all these ideas of data products, associated services and resources, how the relationship with consumers is managed and things are activated, how products are ordered, and what means a life cycle for the provisioning and activation, and how then the rights to use and application and the enforcement of policies is achieved by means of using verified credentials. The FIWARE Data Space Connector is the a combination of modules as I described before. And we will be, through this series of webinars, going through the different components, and the next sessions that will be coming after this one will go into the very details of how identity and access management is implemented and how they integrate with trust frameworks like the one supported by GAIAX, how authorizations is implemented, how all these details about contract negotiation, provisioning, activation takes place and are going to be implemented through a connector. We will go into the details how the policies can be described in ODRL, which is the standard we have decided to adopt for policy definitions. Forgot to mention regarding these contract negotiation, provisioning, and activation, we rely on standard from TM Forum that is a widely adopted industry standard. And we will also elaborate, that would be mostly in session 6 of this series of webinars, how we intend to support some other protocols that within the data space community have been identified as useful, like the transfer process data space protocol, which we will be supporting most probably before the end of this year, but also other things that are in the roadmap. I think very importantly, we believe that the FIWARE Data Space Connector is probably the best aligned with the recommendations coming from Data Space Business Alliance in what refers to identity and access management, decentralized identity and access management, which is key, as the best one that is prepared for integrate with the architecture for marketplaces that the European Commission is setting up for cloud and edge services in Europe. And we are, I think, bringing here technology that is future-proof and will, for those projects that are intending to deploy data spaces and rely on standards that will be the ones that will last and are aligned with the recommendations from TSBA, from Data Space Support Center, and also recommendations and regulations from the Commission, like the digital ID wallet reference architecture, are going to be supported. There were a number of slides, but we do not have time, and this will be covered with detail in the next sessions about the different workflows and how, let's say, we implement each and every of the interactions between a consumer and a data product provider that is offering services through a connector. Let me finish now with this slide, which kind of bring the major takeaways today. Today was more the high-level perspective, understanding what is the kind of problems we wanted to solve with data spaces, and why data space technologies are helping to solve them. And FIWARE, I think we have a good track record in moving from vision to execution. This is what I think we are doing in data spaces, and definitely how I believe FIWARE Technologies is bringing the opportunities for organizations to really rely on things that are going to be future-proof. It's based on common ideas that we have developed with other relevant organizations, GaiaX, IDSA, Big Data Value Association. Indeed, our data space connector, we will be showing this along the different webinars in this series, and are, from our point of view, the best aligned in all what regards to decentralized identity and access management, which is a key aspect of data spaces, the integration with the trust framework, and also how to support integration with marketplace architectures like DOM. And well, this is what we are going to go through during the different sessions, and I rather encourage you to attend and hopefully enjoy those sessions. And after all of them, you will be for sure in the best position to join us and data space community activities, and also getting all our support when deploying data spaces within your projects. Thank you very much. I think we do not have time for questions, and what I would, for this, what we have somehow thought is that the last session, section 6, will be the one where we will be opening a specific part or segment of the webinar for questions and answers. That would be a more dynamic session. So let's go to the other webinars and gather all the information, and we will have also a wrap-up and final session, session 6, on November 21st, if I'm not wrong, where we will be open to answer all the questions you may have. Thank you very much.